Okay, so we're looking at exercise 4D from the second year Stats and Mechanics textbook. So we're looking at moments, and this exercise is on the centre of mass. So question 2, we've got a non-uniform bar. So that statement there is what tells us that the centre of mass is not going to be working through the centre of the bar. And the bar is AB, and there's supports at A and B. So there's supports at either end, and then we're given the two reaction forces. Okay, so let's get a sketch of all that. So I've got bar AB, I've got supports at A and B, so therefore there will be a reaction at A and a reaction at B, and I am also told that the reaction at these supports is 3G at A and 7G at B. Okay, so part A is state the weight of the bar. Okay, so if I go back to my my sketch of the rod, so I've got the two reaction forces, and then obviously there's the weight of the rod itself. So I haven't yet found where the centre of mass is, but just from looking at this, if the reaction at B is greater, the centre of mass must be closer to B. It wouldn't matter if you didn't sort of have that in the correct position, but it must be closer to B than A. Okay, so I've got the weight of the rod, and they're asking me what it is, and they're saying state the weight. So this isn't an exam question, so they haven't given us the mark allocations, but this would be worth just 1 mark. Okay, and your clue is the fact it says state. So I can do that without worrying about moments. I can just do that from resolving vertically. So the upward force is the 3G plus the 7G, and that must equal the downward force. So the weight is 10G, and of course that's not 10 grams, that's 10 times G, and we always take G as 9.8, so that would also be 98 newtons. And in fact, I should really include the newtons there as well. Okay. It didn't say to leave it in terms of G, and they've obviously given their weights in terms of G, or their reactions in terms of G, so 10G would be sensible to be consistent, but 98 newtons would absolutely be fine. Okay, and then find the distance of the centre of the mass of the bar from A. Okay, so that's going to involve taking moments. And I am going to take moments about A. That I think would be the most sensible thing. So I'm going to take moments about A. I need the distance of W from A, and obviously I don't know that, because that's what they're asking me to find. And I'll need the distance of B from A, which I do know, because that's the total length of the bar, which is 5 meters. Okay, and I also know that the weight is 10G. Okay, so if I take moments about A, you could take moments about B as well. So if you've tried this question and you were taking moments about B, that's absolutely fine. You'll just get this distance here, and then you'll have to take that away from 5 to get the distance they've asked for. Okay, so if I'm taking moments about A, there's 2 forces that are going to be causing a turning action about A. One is the weight, and that's going to be trying to turn it clockwise. So the moment due to the weight is going to be the force of 10G times the perpendicular distance of X. That's what I'm trying to find. And that's the only clockwise turning force, and it's not turning, so that must equal the anti-clockwise turning force, which is going to be due to this force here. So that's going to be the force going upwards at B, which is 7G times the distance from A. Okay, so all I'm using there is that the moment, the turning force, is the force times the distance. Okay, that's just how you calculate the moment. Okay, so that's fine. I've only got one unknown, so 10G times X is 35G. So X is 35G over 10G, so 3.5 meters. And then we can have a quick check as to whether that seems sensible. Obviously, we can You can check the answer in the textbook, but we'll think about what if you didn't have access to the answer. And yeah, so firstly, well, 3.5 meters is less than 5, which is the total length of the rod, so that's good. And we said at the start that if the reaction at B is greater than the reaction at A, then the weight of the rod must be acting closer to B than to A. So I'm happy that it's over halfway along the rod. Okay, and then just triple check. Yeah, lovely, you get the same answer.